Hi, and welcome to this video from the algebra section. In this section, this is our second video on sequences. In the first video, we looked at how we can use rules to make sequences. In this video, we're going to look at how we can look at a sequence and decide what the rule is going to be, which is the slightly harder of the two skills. So here we go. So there we've got a sequence of numbers, and we might say, okay, well, that sequence of numbers, how would you describe it? You say, well, you know what, that's kind of simple. That's going to go up by 4 each time. To which we might say, well, okay, well, how about this sequence of numbers? And you go, well, same as again, that one's going up as 4s as well. But what we've got there is two completely different sequences, but you've just described them in the same way. So we need a better way to be able to describe those two things, because just saying, oh, they go up in 4s is not quite enough. We need to be a bit more specific. Now, you might want to say for the first one, it starts at 1 and then goes up in 4, and this one starts at 9 and goes up in 4. But you know what, we can do slightly better, and as you probably guessed, we're going to do this algebraically. So let's have a look at how we can describe this sequence of numbers using algebras, and particularly using letters. So we're going to use the same principles as we had in the last video, using that thing as n. So in each term here, this one we've got n is worth 1. Here, n is worth 2 because it's the second term, n is worth 3, it's the third term, and so on. And what we're going to try and do is come up with a rule that links these numbers here, the ones at the top, with the term that we're interested in. So, first thing to note is this sequence is going up in 4s. I hope that's what we said in the last slide. And so what that actually tells us is it's based on the 4 times table. It's built around the 4 times table because the 4 times table also goes up in 4s. Fairly obviously. So let's have a look at the 4 times table. There it is. And we can see that from the 4 times table, this number here, 4, is 1 times 4. 4 times 1. This is 4 times 2, 4 times 3, 4 times 4, 4 times 5, 4 times 6. So what we can say is the number here on the 4 times table is 4 times where the term is in the sequence, or 4 times the value that we're using for n. So what means algebraically, we can say that the 4 times table, we can describe it as 4 times n, or 4n. Okay. Now, what that means is now, once we've figured that out, all we've got to do now is take these numbers here, our 4 times table, which we know is 4n, and say, well, how can we get from there to the numbers that we're interested in? So, what do we need to do to get from our 4 times table to our sequence of numbers? And hopefully you can see each time if I look at this one here, I'm going from 20 down to 17. What have I got to do? Well, I've got to take off 3. Is that the same thing that's happening here? 16 down to 13, I'm taking off 3. 12 down to 9, take off 3. So each time we're going to do a take away 3. So what that means is my rule is simply going to be 4n and then take away 3. So there we go. So let's just see if it works. So if I've got, my rule is 4n take away 3. Let's have a look at this one here, for example, where n is worth 2. If I do 4 times 2 is 8, take away 3, yes, I do get 5. So the rule is working. So when you come up with the rule, you can always check to see if it works for each of your terms. Okay, so we had 2 sequences on the other slide. Here was the other one. So this one starts at 9, 13, 17, 21, and so on. And we know that one goes up in 4, so we know it's based on the 4 times table, so we know my rule is going to contain 4n. So now we're thinking, how do I get from the 4 times table up to my term? So here's my 4 times table. 4, what have I got to do to get to 9? 8, what have I got to do to get to 13? 12, what am I doing to get to 17? And hopefully we can see that each time we're going to do an add 5. So the rule becomes 4n plus 5. Okay, so that's how it works. Let's have a look at another couple of sequences and see if we can figure out what the algebraic rules for these 2 sequences are going to be. So here we go. For the first one, what we're doing is it looks like it's going up in 3s. So 2 plus 3 is 5, plus 3 is 8. So it is going up in 3s. So that means it's based on the 3 times table. So straight away, I know that my rule contains 3n, because that would be my rule for the 3 times table. Let's have a little look at what the 3 times table looks like. There it is. And so now what we're going to do is here's my 3 times table. How am I getting from my 3 times table to the numbers that I want? What have I got to do each time? And hopefully we can see that each time what we're doing is we're going to add or subtract something, and hopefully we can see each time we're going to do a take away 1. So my rule is 3n minus 1. Right, the next one. This one's a little bit more difficult because what's happening is it's going down. But because it's going down, what it means is it's based on the minus 2 times table because we're taking away 2 each time. So what that means is it's going to contain minus 2n. Now, this thing here, what does that mean? What does the minus 2 times table look like? Well, it starts at minus 2, and goes minus 2, minus 4, minus 6, minus 8, minus 10. It keeps going and going and going. And again, we're going to say, well, what have I got to do to get from my minus 2 times table to the sequence of numbers I want? I'm going from here, minus 2, I'm going to be adding to get to 12, minus 4, what am I adding to get to 10? Hopefully we can see that each time we're adding 14. So my rule would be minus 2n plus 14.